Hey guys, so I'm going to talk through the vocab since I am gone today. Go ahead and fill out the vocab, and then today you will have a crossword as well. So our vocab for this unit, first term that we've got is population. And so in terms of data and statistics, the population is your total amount. Oh, that's too thick. Of data. Okay, and so a population is literally like everyone everywhere. Everyone everywhere. Okay, it is the true total. A sample, though, is just a portion of that data. And so when we talk about population and sample, it's going to come into play a lot with standard deviation. But the big aspect, and also mean, is talking about, is this going to relate to everyone, or is this just a portion and then we're going to modify from there? Okay. Next one is a data point. So a data point is a specific piece of information. And so that could be like we've been talking, like last week we were talking about like the Netflix and TV shows. And so your data point might be like 5 hours as one of those specific data points. A lot of times we will use the variable X for our data point. Okay. Next one is a frequency distribution table. We have actually been talking about frequency tables, but when we talk about frequency distribution, it takes it a little bit different because it's going to list all the data points and then how often they have, versus our frequency tables we were looking at were comparing different categories of certain things. This is just a data and then how many that you have. So it's going to be a table listing data points and how often it occurs. Okay. Now, relative frequency, that's going to be a data point that's represented as a percent of a distribution. And so typically relative frequencies, that's where we're finding like the actual chance that you are that data point versus like just the data point itself. Okay. Then the next two that we've got are histograms and pie charts. These are both going to be different ways that we represent our data. We have so far looked at dot plots and histograms. Most data is given in kind of a histogram style because of frequency distribution tables. They really relate back and forth, and that's where data is grouped into the intervals. The reason that you like the grouped data is because then it helps to kind of condense your data versus having to list every single spot. Whereas a pie chart is where you're actually just looking at your relative frequencies. It's depicted in proportion of the whole. Okay. So this is what we're going to start off with, is just really talking about all of the different ways that we represent the data. And then after that, we start diving into how we analyze the data. And one of those key pieces for analyzing data is a notation called a summation. So a summation, it looks like a capital E-ish. Okay. Sometimes you will see it with a tail. Sometimes you will see it like straight and perpendicular out. Really, it looks kind of like a pointy E as a capital E, but a summation is an operation, and that operation is depicting adding all of the numbers that are within a range. You use a summation to find the mean, and that's what the next thing is. A mean is your sum of data, and then divided by the amount of data. And so when we think about it in terms of notation, that means I'd sum up all my X values and I divide by N, where N would be how many data points that you have. But I want to talk about the notation, because we actually have two notations because we have two different ways of representing data, which is population or sample. So if we're talking about a sample versus a population, Okay. A sample, we're looking specifically at those X values. And so what we call it is we say X bar. We put a bar above it. So it's called X bar. Okay. Whereas with population, we start going into the Greek symbols. So this is called mu. It looks literally like if you were to add an extra tag to a U, or like a pointy M, or an MU, or like a cursive U. So mu is talking about a population. So if I were to, I could say that like X bar would equal the sum of X all over N. Grouped data, however, when we look at the grouped data, because we're talking about the frequency of certain numbers, which we'll dive into, it's the sum of F times X all over N. Okay. So those are two of our notation pieces, but then we've got a couple other different mathematical terms that we look at. So we've got median, which is your middle value when in order. Okay, we were talking about that last week. The mode is your most often data point. And so we will be focusing on mean, median, and modes this week. And then we also talk about the deviation. Now, the deviation was what we were talking about at the Netflix when we were seeing about the spread of data. Your deviation itself is just that first step, which is your difference of a data point and the mean. It's that first subtraction that happens. And then that second step that we do where you're squaring them, that has to do with the variance deviations. And so we have the sample variance deviations. We usually call it S squared for sample. And so those deviations are by dividing the sum of the squares of the deviations by n minus 1. And this, we are focusing on sample. We will dive into more of why it is n minus 1. So S squared, it would be the sum of X minus X bar. Those are all your differences squared all over n minus 1. So we'll actually, the difference of the data is X minus X bar. That was us subtracting the data point X minus all of those mean values. Okay, so sample variance is where we square them all and then we like find that average, which goes into the sample deviation, which the sample deviation is just going to be S, and that's where you take the square root of that variance. So S squared, and you take the square root. Now, that again is for sample. When we're talking about population, we'll put it over here. For population, we use sigma. Okay, sigma looks like a kind of a curvy X, okay, or sorry, curvy 6. And so when we're talking about population, we will use sigma. When we're talking about the sample, we use S. So that'll be kind of the first half of this unit is going back and forth between like histograms, mean, median, mode, standard deviation. Then we will connect it all together with what is called a normal distribution. It is a normal distribution curve. It is a bell curve, which is symmetric. And it represents the percents of data within the set. So a normal bell curve, I want you to think of like, you can kind of think like a upside down, like the little pop-it things that used to be. And we're going to have different values that happen within that normal distribution. And super close to like normal distribution is what are called z-scores, and that is the placement where the data set lies within a standard deviation. Okay, so last week when we were talking about the spread of data and we were talking about that standard deviation, you can be multiple standard deviations away, and it's just that you start getting like less and less popular or less and less likely of that happening. So when we talk about z-scores, it's going to be z equals, you take your data point and you subtract your mean, okay, x minus mu all over sigma, which is your standard deviation. Or if we're thinking of samples, it'd be x minus x bar all over S, okay? And that'll give you your z-score. It tells you literally for how far away you are, what portion of the standard deviation are you away. And then we will end this unit with what is called margin of error. It is my favorite notation. It's just called the MO. And that is your predicted amount to be off from a set of data. Basically, your margin of error is saying, okay, this is our statistic, and this is how accurate our statistic is based off of the sample that we've used, the z-scores of it, and everything like that. So your MO, margin of error, is equal to z alpha over 2. Best notation ever, z alpha, okay, all over 2 radical n. So alpha, you guys, this is alpha, Greek symbol, and so this is said as z alpha over 2. And that's what z alpha over 2 is. That's how you say it. Okay, so z alpha over 2. And we will be doing that towards the end. So this will be in March by the time we start talking about margin of error as we go through. So that is our vocab. Make sure that you get that down. And then next you guys are going to do a crossword. That crossword, for some of our terms that have dashes or spaces, you will use that space in the crossword. Okay, see you guys tomorrow.